Hello and welcome to today's MSSQLtips.com webcast. What's new with high availability in SQL Server 2016 and Windows Server 2016? Sponsored by SIOS Technology. I'm Jeremy Cadlick, co-founder of MSSQL Tips and today's webcast host. Our presenter today is Dave Birmingham, who is a technical evangelist at SIOS as well as a Microsoft Cloud and Data Center Management MVP. He'll be discussing the newly branded always-on availability groups, Cloud Witness, Storage Replica, and SAN clusters. We will also learn about a valuable solution from SIOS from Tony Tamarchio. Before we get started, if you have any questions, you can submit them at any time during the webcast by entering the questions in your question area of your presentation controls. We will try to answer as many questions as possible during today's webcast. If we are unable to get to any of your questions, please rest assured we will follow up with you via email after the event. If you have any technical issues with the sound or screen quality during the webcast, please use the question area to let us know. Also, if you're not already a member of the MSSQLtips.com community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter. Read any of our tips, download the white papers, and watch any of our archive webcasts. Please keep in mind this webcast will be recorded and archived for future playback. You will receive a follow-up email with the links after today's webcast. At this time, I'm going to turn things over to Dave. Dave, can you please take it away from here and help educate the community?
Yes, I can. Thank you very much, Jeremy. So welcome to the webcast. Again, my name is Dave Birmingham. I am going to be talking about high availability features in both SQL Server 2016, which was recently released, and the upcoming Windows Server 2016 release, which Microsoft has just said should launch sometime around Ignite at the end of September, so we're looking forward to that release. And what we're going to be talking about today is really specifically some of the high availability features in both of those products. It's not going to be, it's not going to cover all the new features in those products, but really the features that are going to impact the SQL Server DBA. So we're going to take a look at those features. I've been involved in cloud and high availability for the past 13 years as an employee at SIOS Technology, where we're focused on high availability. And for the past 6 years, I've been honored to receive the Microsoft MVP award, first in failover clustering, and most recently in cloud and data center management. So any questions you have in those topics, feel free to shoot them my way. So we're going to just jump right in. So we're going to start with Windows Server 2016 and some of the new features in failover clustering. The first new feature is one of my favorites, called Cloud Witness. Before we get to that feature, I'll give you a little history of what a witness is. So if you've ever built a cluster or even always-on availability group which leverages failover clustering, you've had to deal with the quorum. Traditional clusters used what was called a disk witness, and you will configure a node and disk majority quorum, and that was for your failover cluster instances. So kind of pictured here, 2 or more nodes connected to some sort of shared storage, and you would have a small LUN that acted as a witness in your cluster, which is essentially another vote to help determine which node comes online. Well, beyond the disk witness, there's also another witness type called a file share witness. So you can implement a node and file share majority witness, kind of pictured here, where instead of using a shared disk, you could have a file server that was hosting a simple file share that could act as a witness. And that was important when you started seeing exchange availability, the DAG groups, so implementing exchange high availability without a SAN, and that was where we first saw it. Then when SQL Server started leveraging failover clustering for always-on availability groups, again we would leverage a file share witness in our cluster configurations, because typically we weren't dealing with a SAN at that point. So that's what they had starting in 2008. We had that. Problem with the file share witness is pictured here. So if you're implementing a multi-site cluster where you have nodes in one data center and nodes in another data center, in order to really implement automatic failover for disaster recovery, implemented safely, securely, without risking false failovers, it required a third data center. and that third data center is where you would put your file share witness. So that obviously was an added expense, complexity to the environment that really was a hurdle that many people just couldn't get over. So what they did is they've introduced in 2016 something called a cloud witness. And now there's a new core model called Node and Cloud Witness Majority, where you can leverage the Microsoft's Azure cloud, specifically their Azure Blob Storage, as a vote in your cluster. And that eliminated the need for that third data center. So now you can have failover clustering, stretch clusters without requiring a third data center. It's very, we're seeing a demo here in a minute. It's very easy to configure. It's very low or almost no cost alternative to file server cluster, because there's very little activity in that blob, so you might not even see any cost at all involved with implementing this cloud witness. So beyond, replacing the need for a third data center in a multi-site cluster, Cloud Witness is also very good in a few other use cases. So multi-site clusters, obviously we talked about. SQL Server always on availability groups. Again, there is no SAN, so there's a file share witness. But instead of managing that whole file share witness and then the availability of that file share witness, as long as your nodes are all connected to the internet, you can just simply leverage the cloud as a witness instead. In the cloud itself, so if you're implementing clusters in Azure or even other cloud providers, Amazon EC2 or whatever it might be, again, you're typically building clusters that don't have shared storage, so there is no possibility of a disk witness. So leveraging this cloud witness is a great alternative for that. And finally, one of my favorite solutions, or what I'm most excited about, really is the branch office scenario. So I've talked to customers, large retailers in particular, that their goal really was to implement a 2-node Hyper-V cluster in each location, and then put some virtual machines in that Hyper-V cluster and have some sort of availability. So they run all their, the cash register and any other, systems they need to run on those virtual machines, but they want to have some level of availability. They didn't want to, buy a SAN for each data center, and they were hoping to get away with just 2 servers and put them in a failover cluster running Hyper-V. The problem always came down to the quorum model. Without some sort of witness, they were really stuck with either implementing a small SAN or putting a third node in each location to act as a file share witness. Now they can have what they were originally wanted, was the 2-node failover cluster using Hyper-V, and have high availability in each of those branch office locations. So that's really going to be a very popular solution, I think, out there. So we're going to jump into a little demo here of how to configure this cloud witness. It's very simple. So this is, if you haven't seen it before, this is the Azure portal, and you can sign up for an account very easily. And all we're going to do is create a new storage account. So we'll see here how that works. We're going to go to storage account, create one, give it a name. This is a unique name amongst Azure itself. And deployment model can be either, but we'll just stick with the resource manager deployment model. The important thing to recognize here is the replication. We're going to change the replication, you'll see here in a moment, to be locally redundant. That's a requirement. You have to change it from the default. And then you can put it in its own resource group. If you're not familiar with Azure, you don't really have to worry about much of this. It's very simple to implement this cloud witness. So when we have that storage account created, we're going to go in and get some of the security so we can connect to this account. So once it's created, we have that Datakeeper Win 2016. We're going to go in and get the access keys. So we click on the access keys, and we'll see our security keys here. And we're going to copy key 1, copy it to the clipboard. And we're going to use that in a moment here when we actually configure our failover cluster to use this cloud witness. So we jump over to Failover Cluster Manager. It's very similar to what we've seen in earlier versions of Windows. It's not drastically different. So we're going to go and we're going to configure the cluster quorum settings. So let's go ahead and watch how this happens. So configure cluster quorum settings, and you'll see here that there is now something called a cloud witness. So we're going to choose a cloud witness. And all I have to do is type the storage account name and paste that storage account key that we just copied. So I pasted the key. This is the name I gave that storage account earlier, and this will connect directly into Azure and create that cloud witness. And that's it. Next. And now we have a cluster that uses a cloud witness as our witness. So very simple, very easy to do, and low cost. I really can't see a reason not to use it. So moving on to the next feature in Windows Server 2016 that's introduced is something called Siteaware clusters, and this is something I've been asking Microsoft for quite some time. Is that at SIOS we deal with a lot of customers building multi-site clusters with the replication solution. One of the problems we always had was controlling, if they wanted automatic failover to the DR site, it was hard to really control the order of which nodes come online. So before 2016, we had something called, we could set preferred owners. So in this case, where we have maybe our primary site is Chicago, the DR site of New York, and we wanted to try to keep things running in Chicago unless Chicago was completely offline. So you think, well, that's easy. Let's set up the preferred owners and say node 1 and node 2 are my preferred owners. Okay, so we have that set. So I'm running on node 1, and I'm going to do some maintenance on node 1, so I move the workload to node 2. And that's great, so everything's still in Chicago. I've done my maintenance on node 1, but I haven't moved things off node 2. Now, before 2016, if there was a failure of node 2, things would actually fail over to node 3. Because what happens is under the covers, even though we set the preferred owners as node 1 and node 2, Microsoft appended to the end of that list the remaining nodes, 3 and 4, unbeknownst to us. So it really just follows the list of preferred owners. So since we were running on node 2, it would fail over to node 3, and that's not what we want to happen. And we only want to go to New York in the event of a complete disaster. So, and then if node 3 failed, we go to node 4. So now we have something called Siteaware clusters, and this is an example PowerShell script of how to configure this. We'll talk through this a little bit. So first what we're going to do is create the site fault domain. So you'll see I created a new site, one called Chicago, description of primary, and a location, and then I created a site called secondary. After I have those two sites created, now I'm going to assign nodes to those sites. So the second part here, I put node 1 and node 2 in the Chicago site, I put node 3 and node 4 in New York City. And then optionally, you can set a preferred site. And by doing preferred site, it controls a few things. One of the things is controlling the dynamic witness and quorum, so we'll talk about that in a moment here. But so I set the preferred site to Chicago. So now I have the preferred site set up, the same scenario. If I'm doing maintenance on node 1, move to node 2, and I'm done maintenance on node 1, so if I have a failure on node 2, it moves back to node 1. So the way it works is that in a failure scenario, it will always choose a node in the same site whenever possible. It will only fail across sites if no nodes remain in the same site. So now if node 1 fails, node 3 will come online. That's what we want it to happen. So that fixes the problem that was been out there for a while. So now it's running on node 3. And let's say the Chicago comes back online, so those nodes are available once again. But again, the way that it works is now if node 3 fails, it's going to choose a node in the same site that it's running. So it won't go back to Chicago until you manually move it back to Chicago, or all the nodes fail in New York. So that's a big improvement over how it worked before. The other thing that setting the preferred site does for us is that it impacts the dynamic quorum, replacing the need to set the node weight. So if you're following along, in Windows Server 2012, they introduced something called dynamic quorum, and in 2012 R2, they introduced something called dynamic witness. Before that, you really had to manually make sure that your cluster always had an odd number of votes. And the reason being is that if you don't have an odd number of votes, if you lose half the nodes, the other half cannot form a majority because it's only half. So those nodes would also come offline. So it's always best to have an odd number of votes. And the way that Microsoft does that now is as things fail, like in a normal circumstance, and what we're looking at here, I have 4 nodes plus a witness. That's optimal. That's 5 votes. But let's say my DR site, node 3 went offline for maintenance. Well, that would give me 3 nodes plus a vote. That's not optimal because that's 4 votes. So what it would do is it would actually take the vote away from the cloud witness, so that you were left with 3 votes. And the same thing happens. It will also take votes away from nodes. If the cloud witness went away, it would actually remove a vote from one of the nodes. So in this case, because Chicago is the preferred site, it would automatically take a vote away from either node 3 or node 4. So that will happen automatically. All right, so next feature we're going to talk about in Windows Server 2016 is something called Storage Replica. And Storage Replica is simply software-based synchronous or asynchronous block-level volume replication solution. It integrates with failover clustering to enable multi-site clusters. It can be used also on standalone servers for basic server-to-server or server-to-self replication. And one of the limitations of it, it only has a single target, so you can only replicate to one target. So here's some pictures of how storage replica can work. So this is enabling a multi-site cluster. So what we have here, we have node 1 and node 2 connected to some shared storage in Chicago, and I have node 3 and node 4 also connected to some shared storage in Chicago. And in this case, node 1, 2, 3, and 4 all participate in the same failover cluster instance. However, the shared storage in Chicago is not available in New York, and vice versa. The New York shared storage is not available in Chicago. So this is where the storage replica comes into play. It's going to actually replicate the data from Chicago to New York over SMB3 and allow you to stretch that Chicago 2-node cluster to 2 more nodes in New York. So you have basic failover from node 1 to node 2, and things will still continue to work and replicate to New York. And if you eventually you fail over, if you have to fail over to the DR site, it will come online over there, and the storage over there will then replicate back in the opposite direction to Chicago. So it allows you to implement a multi-site cluster. The other thing that you can do with storage replica is simple data replication. So if you don't have a cluster but you just want to replicate data from one server to another, you can implement that as well. So you would manage the replication process through PowerShell. There's no GUI at the moment for this, so everything is configured and managed through PowerShell. It gives you a simple way to do block-level volume replication from one server to another. And then finally, the third scenario that they describe is called server-to-self, where you might have an E drive in your server, and it could replicate to the F drive in the same server. And so why would you want to do that? Well, you could do that if you wanted to have maybe your E drive is sitting on some high-speed local flash device, but you're concerned that that flash drive could fail unexpectedly. So then you have your F drive attached to some iSCSI, and you want to do some asynchronous replication so you don't impact the write performance of your flash drive, but you still have a pretty near real-time copy of your data in your iSCSI array. So it's a simple way to just give you some data redundancy in a single server. So Storage Replica, it has a pretty neat feature called test-sr topology, and that's the PowerShell command. And you don't even have to have Storage Replica configured to use this command. You just have to have the file server role enabled on the two servers you want to test. So if you run this command, you see the examples here. You have to pass the source computer name, the source volume log name, so the G drive, the source log volume name. So I should back up for a moment. So in order to implement Storage Replica, you're going to have, it replicates the entire volume. So we're going to replicate the G drive from SQL 1 to SQL 2 in this scenario. And we also need another volume that's dedicated to hold the log files of the replication. And that will ensure that if there's network connectivity problems, interrupts the replication, we can still track those changes so that when the network resolves itself, we can catch up on those changes. So you have to designate a volume that's going to be replicated and another volume that's going to be used for the log file. And the same on the destination computer. You need to have a volume that has the same size as the source, and you need to have a log volume on that destination as well. And in this scenario, I was running the test for 1 minute and storing the verbose results in the directory there. So when we ran that test, it gives you, the output looks like this. Over the next few slides, I'll show you the output. So it's really nice it kind of verifies you met all the prerequisites. First off, if there's a problem with any of your configuration, it would error out and tell you what that problem was. But in this scenario, there were no errors, no warnings, so everything looks like it's going to work well. And it gives you a list of all the tests that it runs. Make sure the partition is set to GPT, which is required. The file system is correct. So it checks all the types of things. The latency is something that's important. If you're doing synchronous replication, the recommendation is 5 milliseconds or less of latency. So you want to, that'll check for the latency as well. And so it does all those checks. One really cool thing, it gives you an estimate of the initial sync time. So depending upon your network configuration, your storage speed, it will give you a pretty accurate estimate of how long it will take to get that volume in sync. So you see that in the report there. It gives you some replication log sizes, and then we're not actually writing anything to the disk at the moment, so everything was 0. But if you were running this on active server, you get some pretty relevant information there. Gives you the I/O latency, that it's completely generally less than 1 millisecond for writes here, for simulated writes to the source log and destination log, so it looks pretty good. Again, we weren't running any, writing anything to disk at the time, so we're not seeing any sort of disk change rate here. But if you were running this in production, you can actually see what your writes, your megabytes per second are in that time period that you measured. Same with the source log disk performance. You see some of the some writes there from some of the tests, but you get more information if you're running this on an active server. So that's the storage replication test report. So it's a pretty cool tool that you can run even before you implement the storage replica. So I have a quick demo here that will show you how to configure storage replica in a situation where you want to replicate a 2-node cluster from one site to another. In this case, I just have an empty role, so it's not a file server, it's not a SQL server or anything, it's just an empty role just for demonstration purposes. But it's a simple role, and it has a single disk attached to it, so this is a shared storage. This is important to realize. So when you're configuring this multi-site cluster, it still requires on either end cluster-aware disk or otherwise disk that support SCSI-3 reservations. So that has to appear in your cluster as a physical disk resource shared between 2 local nodes, 2 or more local nodes, and 2 or more remote nodes. So in this case, we have a storage. The volume you want to replicate needs to be part of the cluster resource, and then you also need to have another volume that's in available storage that's going to act as the log file, but it shouldn't be in your actual cluster. So I'm going to play this and show you. It's pretty simple to set up once you have everything configured properly. You right-click, choose Replication, choose Enable. I'll walk you through a wizard where we're going to choose a couple of things. First, we're going to choose the source destination, the source volume we want to replicate. And then we're going to choose the target. So that's the target that's available on, I'm sorry, that's the source log file that we looked at there. So again, you choose the log and the volume. And here is the destination data disk. We'll choose that on the destination there. That's for the log files. And so you can actually pre-seed the data. You probably saw that there. You had a choice of just overwriting the destination volume, or if you're able to pre-seed the data, you could do that, and it wouldn't have to do the initial synchronization process. And then you have some options: synchronous replication or asynchronous. For cluster, you want synchronous always to ensure there's no data loss. For longer distance replication, asynchronous replication is going to be the way to go, but that could incur some data loss. And then some other options here, especially for synchronous replication, is something called high performance or enable write ordering. For SQL Server, you absolutely need to enable write ordering. So we're going to choose that. That guarantees the data is always crash consistent, especially when you're having logs and databases on different volumes. You need to do that for sure. So then we'll choose next and next. And that's it. So it's pretty easy to get set up, and once it's set up, it works pretty well for that type of configuration. So now that we've talked about Windows Server 2016, I just want to get a feel for how soon you plan to adopt Windows Server 2016. So I'm going to ask Jeremy to put up a poll here. We'll pause just for a few seconds to let people answer, and then Jeremy can share the results with us.
Great. Thanks so much, Dave. Definitely doing a great job with your session. Really do appreciate it. We do have a bunch of questions. If other folks from the community do have questions, please feel free to put them in the GoToMeeting Q&A session, and we will definitely try to get those answered by Dave. So for our poll, how soon do you move to Windows Server 2016? Immediately? Within the next 6 months? 6 to 12 months from now? 12 to 18 months from now, or 18 months or more from now? So if everyone could please take another 10 or so seconds, we'll go ahead and capture all the votes, and then Dave can continue with his session. All right, I'll give everybody about 5 more seconds, and I'm going to go ahead and close the poll. All right, I'm going to go ahead and close it and share the results here real quick. So it looks like immediately is 3%, within the next 6 months is 17%, 6 to 12 months from now is 20%, 28% for 12 to 18 months, and 33% for 18 months or more. Dave?
Great. Yeah, I think that's pretty typical. You have some early adopters, and a lot of people will do refresh when the hardware refresh comes due. So that's good to know. All right, so moving on, we're going to start talking about SQL Server. So I know it says Windows 2016, I should actually say SQL 2016. Always on AG. And you notice space now between always and on. Well, that's the new Microsoft way of doing things. So it's not a typo. You say always on, now there's going to be a space there. So always on availability groups, I'm not going to go into great detail on what it is. Hopefully, if you've been a SQL DBA for any given time, you've seen it. It was introduced in SQL 2012 Enterprise Edition. Basically, it is I call it kind of the next generation of database mirroring. It allows you to take specific databases and replicate them from one server to another, and the availability group means that you can put multiple databases in a group so that they move together and you manage them together as a group. And so Microsoft has been enhancing always-on availability groups since its release. And in 2016, basically the new enhancement is they give you an additional failover partner. So before 2016, you could have source in 8 replicas but you can only have one failover partner. So you could have, maybe you could replicate synchronously from node 1 to node 2 and set that up such that if node 1 went offline, node 2 would automatically resume those databases on node 2. That gives you some high availability functionality. Now you can actually have a third node that can also fail over. So if you have a failure of node 1, node 2 will come online. If node 2 fails, node 3 will come online and will continue to replicate also, asynchronously up to a total of 8 replicas, off-site or other locations for, reporting purposes or just for extra redundancy for disaster recovery. And you can have a mix of synchronous or asynchronous replication. So again, with 2016, the big change here is now you can have that third node participate in failover. The other thing that they introduced is something called basic availability groups. And so I mentioned earlier, always-on availability groups traditionally have only been available with the SQL Server Enterprise Edition, which is quite more expensive than SQL Server Standard Edition. And what they've introduced in SQL Server 2016 Standard Edition is something called a basic availability group. So it comes in Standard Edition. The limit is it only allows you to have one database per availability group. So it really mimics what you had with database mirroring, which was basically one database at a time. You couldn't group databases together, which had some limitations. So you couldn't ensure that the databases that needed to run on the same server were always running on the same server. But the database mirroring has been deprecated for a while. It's going to go away. So this was Microsoft's answer to what can we offer people who are used to using database mirroring in SQL Server Standard Edition. That supports synchronous or asynchronous replication, but it doesn't have the ability to read from the secondary. So in the enterprise version, you can have a read-only access to the secondaries. You can also do backups from the secondaries. The basic availability group does not allow readable secondaries or taking backups from the secondaries. As again, so it replaces the deprecated database mirroring. The other feature that's coming in SQL, or is available now in SQL Server 2016, is support for Distributed Transaction Coordinator. So there was a big announcement that, because it's always been a limitation, if you were implementing always-on availability groups and you have an application that required distributed transactions, you weren't able to do that. You couldn't use always-on availability groups, and you had to instead use traditional failover clustering because that supports distributed transactions. So it's always been a limiting factor of implementing always-on availability groups. So it would seem pretty exciting. However, they didn't quite get it all the way done. And there's one major, I call it a bug, but it's a feature limitation that's documented in this link here that I have, and I've quoted the important part that says, cross-database transactions within the same SQL instance are not supported for always-on availability groups. That means that node 2 databases in a cross-database transaction may be hosted by the same SQL Server instance. This is true even if those databases are part of the same availability group. When I read that, that kind of eliminates most of the scenarios I'm imagining where people need DTC. Usually if you have multiple instances of SQL Server and you're doing always-on availability groups, you're going to be leveraging those instances in the availability groups. The only way that this would work, guaranteeing that you would never run those databases on the same instance, is if you had different named instances or different instances that didn't participate in the same availability group, and you kept your databases totally separate. So just be careful. If you're excited about DTC support, just look at your architecture to make sure that you're not going to run into this limitation and then have to fail back to using the failover cluster instance. SQL Server 2016, you see a lot of people, there's a hashtag, it just runs faster. So there's lots of improvements in all aspects of SQL Server to make it faster in many different ways. And I just was watching a webinar, there's a new Channel 9 that talks about some of the new ways that SQL Server is faster. One of the things that was always a problem or a limiting factor with SQL Server always on availability groups doing synchronous replication was that there was some problem with the log transport capabilities. It was a single-threaded piece of that that really impacted the write throughput for performance, especially in highly transactional databases. So we saw this early on where people were adopting flash-based storage solutions, and so it's a flash-based storage plugs into the local server in the PCIe slot. It can write extremely fast, but it's only in a single server. It's not a shared storage solution, so they were looking for always-on availability groups to provide some high availability for that. But they found out early on that the write throughput was severely impacted, and they spent a lot of money on flash storage, but were not able to get the performance that they needed because the always-on availability groups just slowed it down tremendously. So this chart I took right from Microsoft documentation. I didn't run these tests myself, but this is what they published results showing today, meaning SQL Server 2014 versus SQL Server 2016. Same test, you see some pretty significant performance improvements, and this is in a configuration where always-on availability groups configured in a synchronous replication mode. So it's going to be better. I haven't tried it. You really pushed it to its limits yet, but I'd be curious to see if they've eliminated all their bottlenecks. So it just runs faster is one of their taglines. You want to check that out. And then finally, in SQL Server 2016, they have something called database health detection now in always-on availability groups. So prior to 2016, if you had a always-on availability group and you're protecting 3 databases in automatic failover mode, if you had a database that became corrupt or went offline or suspect for some reason, always-on availability groups would not detect that failure. It really only detected failures at the host level. So if the host itself became unresponsive, failover clustering, the quorum model would detect that and would initiate a failover of all the databases. So now you have an option of turning on database level health detection. It's in the GUI, as pictured here as a checkbox when you configure the availability groups, or in PowerShell if you want to create your groups there, or when you use SQL Server Management Studio, you could turn DB failover on, and so that will detect whenever a database is offline, and the offline database will cause a failover of that entire availability group. So just be aware of that. Failure of a single database will cause all of them to failover, which is probably a good thing anyway. So second and final poll here before I pass it over to Tony Tamarchio is, when will you move to SQL Server 2016?
Great, Dave. Thanks so much. So as Dave mentioned, the poll is, when will you move to SQL Server 2016? Immediately? Within the next 6 months? 6 to 12 months from now? 18 to 12 months from now? Or 18 months or more from now? And some people are commenting that they're already using SQL Server 2016 in production, so that's great to hear.
Great.
And then I know we're also getting other questions about new development, production, etc. It would basically be production environments that you're looking at. So if you could please fill out the poll, that'd be great, and then we'll continue from here. So we'll give everybody another about 10 seconds or so. If you do have questions for Dave, and we do have a bunch, if you could please post them in the Q&A section of your GoToMeeting controls, we'll definitely go ahead and pass those along to Dave. All right, I'm going to go ahead and close the poll here and share the results. So it looks about 13% immediately. Those also might be folks that are currently on SQL Server 2016. Within the next 6 months, 20%. 6 to 12 months from now, 20%, 12 to 18 months, 20%, and 18 months or more, 27%. Thanks so much. Hey Tony, do you have anything from SIOS that you'd like to share?
Yeah, definitely. If you could pass me control, I'll go ahead and share out my screen. And we're going to be talking about our Datakeeper Cluster Edition solution, which is a software-based replication solution that integrates with failover clustering and allows you to deploy what we'll refer to as Sandless clusters in a lot of different configurations, both physical, virtual, and cloud. So thanks very much. And Dave, great overview on the new HA features related to Windows and SQL Server 2016. A lot of exciting stuff, that's out in SQL 2016 and coming soon in Windows 2016. So I know we've got a lot of questions queued up here, so I'm going to go through just a short amount of content, couple slides, and then a brief demonstration, and then we'll make sure we've got some time to answer all the great questions out there. So with that, let me jump right in. So, I'm talking here about the whole idea of what we call Sandless clustering. More technically accurate term would be a shared nothing cluster configuration. So, similar architecture to what Dave was going through with, with availability groups where you have clusters, not all the nodes are connected to shared storage, and you need a replication solution, whether that's going to be storage replica in 2016 if you do meet the criteria, or there's a lot of other situations where you're definitely going to need a solution like Datakeeper to give you more flexibility in just environment choices, storage choices, and things like that. Now, while most of the time customers are using this type of a solution to protect SQL Server, this does work for any clusterable service or application. Custom service or application, you name it. So it really applies to any type of an environment, server, storage, agnostic here. So going back just to kind of recap, one of the similar slides to what Dave covered, a traditional cluster, this would be your traditional SQL FCI, failover cluster instance. You've got shared disk. This works great if you're talking about, a single site, and if you have a SAN or some type of shared storage there. But technically the shared disk is a potential single point of failure. The whole idea behind a cluster is to eliminate as many single points of failure as possible here. So what Datakeeper allows you to do is it allows you to deploy again, what we call a Sandless cluster. So you have 2 or more servers. Again, these could be physical servers. These could be, VMware or Hyper-V virtual machines, or these could be, instances up in Azure or AWS. Basically, just the drive letters and sizes need to match. So here I've got, this enables you to deploy a fully highly available SQL failover cluster instance. So not just availability groups where it's going to replicate, certain databases. This is going to protect and fail over your entire SQL instance. And Datakeeper is doing replication at the software level. It's going to do block level replication that's synchronous or asynchronous, depending on your network characteristics. You can select the mode that is most appropriate for you. And of course, upon failover, it will go ahead and fail over the protected SQL instance or application, and it will tell Datakeeper to switch the direction of replication here. So, one difference to something that was mentioned earlier is it replicates the volume. You don't need to set up additional storage, right? You don't need an extra log volume for every data volume that you want to replicate here. This just replicates the volumes. There's basically a filter driver that sits underneath NTFS, and we intercept writes and replicate them. So a lot simpler to set up here. Now, you're certainly not limited to 2 nodes. If you want to have a, both local HA and failover to a DR site, and you've got a lot of flexible options here. You could, have 2 physical servers on-prem, and maybe your third cluster node, your second target would be, at another site or even up in the cloud. So you can mix and match physical and virtual and cloud systems within your configuration. So this is an example of a 3-node config with no shared disk. Now, another common scenario that this enables is, what if you already have an existing cluster, right? And you want DR, you don't want to buy a second SAN and go the storage replica route. Maybe you just want to deploy a third server. Could be physical or virtual at the other side, or maybe you want this to be up in the cloud. So this diagram is what I call a 2x1 cluster, meaning I've got my 2 nodes with shared disk, and I've got my 1 node with independent disk. And Datakeeper can give you this added flexibility to kind of mix and match your servers and storage and different numbers of nodes here and there. So a lot of flexibility here. And this type of a config, multi-site cluster is really the best of both worlds. It's both HA and DR in a solution, because you can fail locally, and then if you lose the data center, you can fail remotely as well. So and this is gonna if you expand this to more nodes with the new Windows 2016. The site preference features that Dave just went through a little earlier, I mean, that's going to enhance this even further. So a lot of great enhancements in Windows that are going to make the combination of Windows failover clustering and Datakeeper, even more powerful here. So, hybrid storage configurations are also very possible. Also, a lot of people want to deploy, purely up in the cloud. So, Dave covered the new Cloud Witness feature. So, this is what people have been doing today. 2 nodes typically with a file share witness. Go ahead with Windows 2016, and go ahead and you can do that with a Cloud Witness as well. So, this is what a typical cluster up in the cloud has looked like historically, and really the architecture will look very similar in 2016. You just have the additional option to go with a Cloud Witness. That's Azure. Again, you'll notice the diagram. If you want to do this up in AWS, it looks basically the same. Just some different terminology on the screen instead of fault domains. AWS calls them availability zones, things like that. But it's really the same architecture. So again, you've got the flexibility in where you deploy this and what servers and storage you end up going with here. So very cloud friendly. Probably one of the biggest questions that we get asked is, well, how does this differ from availability groups? And there have been some enhancements, as you heard earlier, to SQL 2016. This just kind of highlights, again, a Sandless Cluster with Datakeeper. It really gives you the best of both worlds, right? You get the shared nothing aspect from an architecture perspective, so this makes it easier to do deployments in the cloud or multi-site and things like that. But here you get full instance level protection like you would with a traditional failover cluster instance. So you don't have to worry about reconfiguring availability groups each time you add new databases. The entire instance is protected. There's aren't limits on the number of databases or AGs that you can protect. The system databases will also be protected, so you don't have to manually worry about synchronizing your SQL logons or SQL agent jobs between different nodes. It's just all going to be replicated and failed over, and that really just leads to lower database administration, more ease of use, less chance that you forget to do something and jeopardize your data protection or your HA. And then of course you've got full application level compatibility, because you don't have to worry about some of those gotchas with DTC in 2016, or if you rely on that prior to SQL 2016, availability groups really isn't an option for you anyway. And then also this gives you full HA, even with SQL Standard Edition. If you want to replicate all your databases and handle that without either making the jump to SQL Enterprise, or we saw here today that SQL 2016 Standard Edition gives you some basic availability group features, but there are a number of limitations. So again, it's really kind of best of both worlds. It's, get rid of the shared disk, that opens up the doors to make this easier to deploy in physical, virtual and cloud environments, and at the same time getting full instance level protection here. So with that, I'm going to spend maybe 1 or 2 minutes to give you a quick demo of Datakeeper, and then we will open up for Q&A. We'll do one last poll at the very end as well. So I'm going to put this into full screen mode here. And what I have is, a typical cluster. Anybody who's set up a failover cluster in the past, you're going to know 99% of how to do all of this. Here I've got a 2-node cluster. This is still using a file share witness. I haven't gone through and configured a Cloud Witness here. But my nodes are SIOS 1 and SIOS 2. I've got a couple of roles here in my cluster, one of which is a SQL failover cluster instance. And this all looks like a typical cluster. I've got my name and IP and resources, and then here's where Datakeeper comes into play. So instead of your physical disk resource, your shared LUN that you presented to your nodes, well, Datakeeper provides what Microsoft calls a third-party storage class resource. So this is our Datakeeper volume resource. And what you see here is this Datakeeper volume S. So it looks and it feels and it acts like shared storage. But in reality, I have an equally sized S drive on my 2 different servers. There's no shared disk at all. I don't have extra volumes here to worry, for the replication metadata or things like that just are, take up additional space on your storage devices and additional, overhead here. So I've got this Datakeeper volume S. So other than this difference of this replicated disk resource, this cluster looks and feels and acts like you're used to. And the way that you get this into the cluster, the Datakeeper resource into the cluster, is quite simple. We have a Datakeeper user interface. It's a MMC snap-in here. And I'm looking at an overview screen. I can see my drive letters and see I already have a couple of drives that are already replicated. I'm going to create a new one here for you today, just simply by creating a job. And I'm going to go through a 3-step wizard, give it a very unique name here, our drive. And I'm going to pick my source, then my target, finally my mirror options. So SIOS 1 will be my source. I'm going to replicate my R drive, go through, pick my target. Actually, nothing to change here. It's pre-selected everything for me. And then finally configure my mirror options. These servers are, in the same data center, high-speed, low-latency network connection. So I'm going to go with synchronous replication here. If these 2 nodes were, halfway around the world, you might want to go with async there. So create this new job. It's going to create the new mirror, replicate the contents of R from node 1 to node 2, and because Datakeeper is cluster integrated and aware, it's asking if I'd like to register this as a cluster disk. So I'm certainly going to say yes here. And that's really all you have to do. You're kind of done with the Datakeeper portion of this. I've got this new mirror, it's part of the cluster, and I can verify that by going here back into Failover Cluster Manager and looking at the cluster disks. And here I've got this brand new Datakeeper volume R sitting right there in the cluster's available storage pool. And really at this point, this is, you're back to clustering 101 here. So do a quick failover just to show you that it does work. So I'm going to move my SQL failover cluster instance from node 1 to node 2, and this is all going to look like a typical failover. It's stopping everything on node 1 and it's starting it up on node 2. As part of that failover process, it is also failing over the Datakeeper mirror, which is telling Datakeeper automatically and under the covers to switch the direction of replication. So now source and target roles switch, so replication will now take place from SIOS 1 back to SIOS 2. So very easy. Again, 99% of this is just what you're used to today in how you've set up and manage your failover cluster instances. Datakeeper is that 3-step wizard that we saw here to enable this Sandless type configuration. So again, this gives you a lot of additional flexibility. Storage Replicate's a great new feature. This gives you some more flexibility, particularly around storage choices. This will work with any block storage. It doesn't have to support SCSI reservations or things like that. So this could be, a virtual instance up in the cloud with just the virtual storage attached to it. This could be, a Hyper-V VM with a VHDX file attached, or a VMware VM with a VMDK file attached, or a physical server with maybe just internal SSDs or spinning disk, right? So you can use any type of storage here. This also, again, does support multi-target, and it works with any edition of Windows and SQL Server. So you don't have to make the jump to, Windows 2016 Data Center Edition just to get the storage replica. If you're good with Windows Standard Edition, which has pretty significant cost savings here, this is going to allow you to achieve cost-effective but fully featured and full protection from an HA solution here. So that's a brief overview and demo of Datakeeper. And why don't we now go back and we'll open it up for Q&A. Actually, we've got one final poll and then Q&A.
All right, so we go ahead and launch.
So here we just want to, oh, go ahead.
No,
go ahead, Jeremy.
Go ahead, Tony.
Okay, just say we have last final poll. We just want to ask if you'd like to be contacted to learn more about Standless clusters and our solutions here at SIOS. Please let us know. We're happy to reach out to you. And while you go ahead and fill out that poll, just if you want to get more information about our solutions here, You can visit us at us.sios.com. We've got @siostech for our Twitter handle. Give us a ring, shoot us an email. We will be at VMworld. We will also be at SQL Pass Summit. So if you're going to be attending any of those shows, please do go ahead and stop by the SIOS booth and come say hi, ask questions, see demos, and learn more about our solutions here. So with that, Jeremy, why don't we start addressing some of the questions that came in during our session.
All right, so I'm going to go ahead and close the poll. All right. All right, so we do have a lot of questions. If there are additional questions folks have, please feel free to post them now. We're not going to be able to address all of them during today's live session, but what we will be able to do is pass those along to Dave and Tony, and they'll be able to address your questions after today's session. So if you do have questions, please post them, and we will get them addressed. So that being said, first question for you, Dave. Do you know if fiber channel shared disk groups are supported in Windows Server 2016? So do we have the ability to create shared group disk pools?
Yeah, so traditional shared storage, fiber channel shared storage in clusters are still supported, and I think it's going to be, still the most common method for failover cluster instances. We say disk pools. I mean, storage pools, absolutely. You can build storage pools on top of shared disk and leverage that. I see that a lot in the cloud, where you have some size limitations, or you're just trying to get more performance out of what's available. So storage pools in clusters and fiber channel shared disks certainly still supported in 2016.
Okay, great. Tony, next question for you. Does SIOS Datakeeper require any special storage or anything? Could you elaborate on that?
Sure, great question. So no special storage. Basically, any block storage will work. So that could be a traditional spinning hard disk or an SSD or a PCIe-based flash card, or it could be a VMDK or a VHD file attached to a virtual machine. So really the requirement is that the storage is presented to the Windows OS as block storage. So fiber channel, iSCSI, those, basically any block storage will work. And when you attach like a disk to an Azure VM or an EBS volume to an AWS instance, it shows up as a block device, and give it a drive letter, and that's all you need to know.
Okay, great. Thank you. Next question for you, Dave. What needs to be done to implement Cloud Witness if your SQL Server boxes don't have direct internet access?
Yeah, unfortunately, internet access, each node needs to be able to access the internet to leverage Cloud Witness. So if you don't have your systems with internet access, you'll have to, still revert to using, file share witness or disk witness. So yeah, internet access is required.
All right, great, thank you. Next question related to a replication. Early in your session, can you explain how the replication is actually handled? I assume this is related back to always on. So is it by the operating system Windows, or some sort of storage, some sort of SAN replication, or is it actually Windows that's replicating itself? Can you elaborate on that?
Mm-hmm. Yeah, I guess it's about storage replica, and that's definitely handled by Windows, the operating system level. Doesn't leverage any sort of SAN replication. So it's a software-based software-based storage replication solution that's handled by the OS. And Windows, all you need is some Windows 2016 Enterprise Edition, and you can do some basic replication from one server to another.
Okay, great. Next question. Can you get into the pricing at all for storage replica?
So storage replica, so some features including storage replica are only available in Windows Data Center Edition. So Microsoft made a change where around 2008, I think they went to basically feature parity across all versions. In 2016, Windows 2016, they've changed that now that not all features are available in all versions. So to get the storage replica, you need the the Data Center Edition, which is listed at $6,155 per core. versus the standard edition at $882 per course, almost 7 times as much to get the features such as storage replica. So, most people are going to have more than one course, so even a 2-course system, you're looking at about a little over 12,000 versus a little less than 2,000 for standard edition.
Okay, great. Thank you. At this point in time, we're going to go ahead and wrap up. We're at the top of the hour. If you do have any last-minute questions, please feel free to post them. Like I said, we have a lot of questions. We unfortunately weren't able to get to them all, but we will pass those all along to Dave and Tony for them to be able to follow up with you. So at this point, just definitely want to thank Dave and Tony for your time, for preparing your sessions, as well as helping educate our community. I want to thank SIOS Technology for sponsoring today's event. I just want to remind everyone that this webcast was recorded. We will be sending out a follow-up email with links to view the archive. Also keep in mind you go check out all the free resources at mssqltips.com. Once again, I'm Jeremy Cadlick from MS SQL Tips. Thank you for attending today's event and have a great day.